Hello, hello. I am Toto Mariko. That's how I go in Discord. You might recognize me. I am doing this Chainlink Hackathon Chromium 2025. And sorry, just a heads up, this is a last minute presentation, so it's not going to be that well put together, but it is part of the submission requirements, so I just need to get this done. Um, this is my project, the Perp Dex Risk Coach. Set this up to wanted to help traders mitigate gambling behaviors using our decentralized tools. Um, I wanted to make a smart contract system to mitigate compulsive trading behavior by using Chainlink functions, Chainlink automation, and ELIZA AI to monitor the DeFi trader performance. Basically, monitor like a subgraph and to have the user input their risk parameters. Say the user has these trading requirements in their mind, like um, to stop trading if they have three losses in 24 hours, or if they have more than 10 trades in 24 hours, then they really need to stick to um, this this parameter. But if they have it in their mind, it's easy just to let that pass. But if we have tools to monitor our actual behaviors and enforce um, some sort of mechanism to make sure that they can't do it anymore, then I believe this would really help some of those traders not um, repeat these patterns. So I originally wanted to use Chainlink functions to monitor the subgraph, which I eventually did, was able to generate HLink functions, which I will get to. Um, I also wanted to use the automation to send requests for the Chainlink function to see if the traders have been good or not. And then I wanted to use Eliza OS to be acting like a behavior coach and also submit maybe some transactions on behalf. Like if the trader is doing really good, the Eliza OS can see their trading stats and maybe unlock their account or let the trader know, hey, their parameters are about to be breached. Make sure your habits are getting better because you're going to get locked out. But I wasn't able to get to Liza, but I still want to build this out in the future. So that's basically what it was. My architecture was React front end, AI coach, Chainlink functions, smart contracts, and there's the tech stack, Solidity, Chainlink functions, which I did use. I did a React Byte front end, um, did not utilize the OS AI agent, and then did the hard hat deployment. Ether, I wanted to inject ethers, but I was getting too many errors and time was running short, so didn't get to that. Also, a side note, this hackathon was really made possible by Cursor and ChatGPT. It was so much more empowering just to be able to produce the nuanced code and help build this out. Um, but there is also needing to understand what's going on, which I'll get back to as we get into the contracts. So the contracts that I was able to use is Guardian, Risk Lock, Risk Functions Consumer, and there's also one other function, the contract that I didn't have in here yet is the Risk Proxy. So first off, the Guardian is pretty much the admin controller. If anything goes wrong with the unlock and lock of their wallet, uh, we can have like a bypass override system. Um, let's see. Risk lock is the central lock contract that will disable the trader, and then the risk functions consumer is the the Chainlink function that does the computation for. off-chain computation for the source script, and then of the source script, which is monitoring, which I'll get to, I guess, but it just monitors the subgraph and then returns the results onto the risk lock contract. So on chain, I did learn about the functions consumer. Everything is still decentralized, even though if it goes off chain, the Chainlink has a decentralized off chain Dawn that will do all the computation. And then it performs the Chainlink contract functions, and that's all on the blockchain as well. So that's that. This is for really for me here to, well, if I need to come back and ship it, like download it from the repo and then install like the Chainlink nodes. Okay, so let's see. Let's go to the contracts. Okay, risk functions consumer. Um, this one. Uh, I learned some things here. When I deploy my contracts, they all have to connect to each other. Basically, we have these interfaces here. That's just telling the contract that, hey, with this contract guardian, there is this function here as well as risk cooldown. There's this trigger risk cooldown. Um, so here's the constructor, basically giving the router, the Dawn ID, risk lock address, pull down proxy, and we send a request. This is for the call Eliza OS to request monitoring of the user. Then we send a Chainlink function request. So this was the one that really I dove deep into. Um, there's some things here that needs to get passed over, like the byte string, like the args, the subscription ID, the callback gas limit, and this gets passed by using the functions request config. And we have some arguments here for the consumer to calculate. This is part of the computation. We pass through some of these values here, like, and then um, send it send it off chain. So we'll do function fulfill request, and then we'll perform function fulfill request, and we'll um, we'll send our source script out, which is batch monitor perennial.js. This is saying, um, where does it connect to? Function fulfill request update. So when we run the Chainlink function fulfill functions request here, it will trigger the source script. And this source script monitors the trading account. Here's the query for the trader, um, and then it'll do the calculations here and to see if we have realized trades or not. Um, and then it'll push. We have a console.log to show what the values are, and then we have like a ABI code here, which is a tuples of the addresses and the lock statuses of each of the addresses that gets returned, and the Chainlink functions will decode it here. Um, they'll decode in the fulfill request. So I was able to run the functions here. Um, let's see. So we got the breach. So we could simulate it without actually sending it on chain, just to see before we actually use the testnet tokens. You can see for this trader, we have loss of one, trades of two, and um, the breach is true. But if we change the parameters again, we could see like, if we actually want to have more than two losses in our risk parameter and more than two trades, uh, then the breach is false. So ideally, the front end would send the functions, uh, pretty much change the functions request here. I think, but yeah, uh, let's go back to Chrome and then uh, let's go to the function. So I was able to make a subscription ID, send the consumer. I tested a bunch of different consumers because before I didn't have the right computation or the callback. Either or were not working. So eventually I was able to make the right adjustments and get the successful callback computations. So, um, this is just a little snippet of what I think it could be looking like. The trader inputs their wallet address, they set up their parameters, and then they just perform the risk check. Right now, I don't have the Ethers plugin injected, so we don't have that, but um, yeah. Eventually we'll connect to MetaMask, they'll perform the transaction, everything will run as designed, like with the actual contract. So here's the results. And yeah, I think that's getting close. So just gonna wrap it up here. I need to submit this. So thanks for your time, guys. And I'm looking forward to doing more. So I'm sure I'll probably see you around. Okay, bye.